Alright, year 8. So here in this video we're going to look at how we can use area to find distances in circles. So using the area to find our radius or our diameter. And again here the key relationship that we're going to use is the same equation, area equals pi times radius squared, or a equals pi r squared. Now just like with our distances, if we had c equals pi d, we could divide through and rearrange it to see what d would be if we knew c. We can do the same thing here. So if we knew a, or the area, we could rearrange this equation to see what r is going to be. So we can use a to find r. So what we're going to do here is we want to get r by itself. So at the moment this is r times pi. So to rearrange it, we're going to divide it by pi, which means we also have to divide the other side by pi, because we're doing the same thing to both sides of the equation. And then to tidy that up, so our left-hand side is going to become a over pi will be equal to, now pi times r squared divided by pi is just r squared. And so that would tell us what r squared is. And then if we wanted to find r, or the radius from there, what we'd have to do is then take the square root of both sides. So if we then take the square root there on both sides, we can see that the square root of a over pi will be equal to the square root of r squared. And we know that the square root of r squared is just r. So we get that r equals the square root of the area divided by pi. And just to be neat, we'll write it the other way around so that we can say r equals square root of a over pi. So we can see that if we know a, we can find the radius, which also means that we could find the diameter if we wanted to by then doubling the radius. So it would just be one extra step afterwards. So here we see, if we know the area, we can find the radius, and which means we could also find the diameter if we know the radius, which is something that we're pretty happy about. So let's have a look at an example here to practice using this relationship to find the radius. So we're told that a circle has an area of 20 square centimeters. Find the radius of the circle correct to 2 decimal places. So let's draw this circle to see what's going on. So we're told that the area, which is a space inside the circle, we're told that that area is equal to 20 square centimeters. Now, if we're told the area and we want to find the radius, we can use that relationship and rearrange the equation a equals pi r squared to have that r will be the square root of a over pi. Just make sure we see that that's a divided by pi and then taking the square root of the whole thing, not the square root of the area and then dividing by pi. So all we need to do to find our radius here is we need to substitute in our value for the area. So we know that the area is 20 square centimeters. So we just replace our a in the equation with a 20. So we're going to show that that's the square root of 20 divided by pi. And now we're asked to give this correct to 2 decimal places. So this would be our exact answer here. But we're asked to give it correct to 2 decimal places. So we're going to use our calculator to do an approximation. So we see that if we put our square root of 20 over pi in the calculator, making sure that both the 20 and the pi are inside the square root, that we get r equals 2.523, 132, and so on. So 5, 2, 3, 1, 3, 2, and so on. And so we're asked to round to 2 decimal places. So 1, 2, we have a look at the third, and that's less than 5. So we're going to round the 2 down to a 2. So our final answer here to 2 decimal places is R is going to be 2.52, and that is in centimetres, because this question was in centimetres. So another example here, we're told that if a circle has an area of 50 square metres, so we know the area is 50 square metres, what is the diameter of the circle to the nearest metre? So we're asked to find the diameter this time and to the nearest metre. So again, let's draw the circle to show what's going on. So we're told there that the area of the circle is equal to 50 metres squared. So we have our A equals 50. Now remember, our relationship for area tells us what the radius is. So we can use our relationship that the radius will be the square root of A divided by pi. So square root of A over pi. And then we'll need to double this at the end to find the diameter. So let's find the value of our radius. We know A, so we can substitute in. So the radius will be the square root of, now our area is 50. So we replace that A with 50, and it's divided by pi. So the square root of 50 over pi, which we can see is equal to, if we type it into our calculator, that is equal to 3.989. Let's get my pen working here. It's 3. And again, we're approximating there. 3.9894, and so on, using our calculator. And now our D is equal to double that, so we can see therefore D, which is equal to 2R, which will be approximately equal to, if we double that value, approximately equal to 7.97. 7, 8, and so on, 788, which to the nearest metre rounds up to 8 metres. We just need to look at that first decimal place to round to the nearest metre. That 9 will round it up. So 7.9 to the nearest metre equals 8 metres to the nearest metre. And so that's how we could find the radius or the diameter. We use the same process to find the radius each time, and then if you're asked to find the diameter, we just have to double it at the end.